Welcome to The Perfect Stool, Understanding and Healing the Gut Microbiome. This is your host, Lindsay Parsons, and today I'll be speaking with Bryce Wylde, DHMHS, a leading health expert and clinician at VenMed in Toronto, founder of MyMunity, best-selling author, previous host of CTV's Wild on Health, and regular guest health expert and medical advisor to the Dr. Oz Show. And most relevant to today's discussion, he is co-founder of the DNA Company, which is focused on assessing personalized genomics and delivering action plans for optimal health. And they did a DNA sequencing and report for me, and we're going to be discussing that and how your DNA relates to your gut health on the show today. And to best follow along with us, you'll find a PDF file on the show notes page on my website, highdeserthealthcoaching.com, under the podcast episode 110 that we'll be referencing. And note that the page numbering restarts with each new section title, so when we start talking, we're going to be on page 10 of the cardiovascular section. Also, I have a few new things I wanted to share with you about new discounts, protocols, and a product review I promised. So I did a podcast on Thanabiotic, the postbiotic supplement made from human stool, which has been killed. All the living matter from it has been killed, which was episode 103. And I promised I'd give a review after trying it. Now, keep in mind, I have a very particular set of issues, which is post-infectious IBS, which causes recurrent hydrogen SIBO. So for me, Thanabiotic made my stool more loose, so it wasn't a good fit for me. However, I might suggest it for someone who's constipated. So if you've tried everything else and have recalcitrant constipation, then that may be a good next option. If you're interested in trying it, you have to order it through a practitioner, so you can reach out to me at Lindsay, Lindsey, at highdeserthealthcoaching.com or find my email in the show notes. On another note, I constructed a new GI issues supplement plan on FullScript where I give my listeners a discount on practitioner-grade supplements. In it, I suggest supplements for constipation and loose stool and general GI issues with supplements that won't wipe out your microbiome or likely cause any adverse effects. So if you're looking for somewhere to start and aren't quite ready for health coaching, you can check that out from the link in the show notes. And you'll be able to see which supplements are recommended and in what order for which symptoms. And finally, I instituted an additional 5% auto ship discount in FullScript. So if there are supplements you get monthly or every 2 months and you add them to auto ship, you'll get another 5% off, or not just every 2 months, it could be every 6 months. So that's another opportunity to save and support the podcast at the same time. And they have all the major practitioner grade supplements in there, including Designs for Health, Pure Encapsulations, Biotics Research, Thorne, Metagenics, Microbiome Labs, Integrative Therapeutics, Vital Nutrients, Seeking Health, and many more. So check it out and support the podcast while getting supplements at a discount. If you haven't yet followed or subscribed to the show, be sure to do so. And if you want to get transcripts of the podcast, pop over to my website, highdeserthealthcoaching.com, and sign up for my newsletter. You'll also get my free e-booklet, Finding Your Root Cause Through Stool and Organic Acids Testing, when you sign up. And if you haven't yet done my quiz on which stool test would help you get to your root cause, you can find a link in the show notes and take that. Now on to the show. Welcome to the podcast, Bryce.
Thank you so much.
So before we launch into my DNA results and what they say about my gut health, can you first tell me about how you arrived at the conclusions that you make in the DNA reports from the DNA Company?
Sure. Well, I had the privilege of understudying with Dr. Mansoor Mohammed, who's revered probably through most genetic experts, genomists around the world as within the top 10. So I've been in clinical practice over 20 years, and we shared a significant degree of patients between us in this very eclectic, multi-centered practice called P3 at the time. We since no longer practice under the same brick and mortar, but with his IP and his insights was born a lot of what you would see in this particular DNA report.
Okay. And this was based on patients that he saw and in their DNA reports, or?
Yeah. So Dr. Mohammed had a long-standing company and had seen at the time, I believe it was about 2,000 individuals, patients of his that he'd done genetic reports on, double, PhD, UC Baylor and UC Davis graduate, focused in exactly this, genomic pathways. And so at that time, and then together, along with a team at the DNA Company, amassed another 6,000 or so patient samples. And so, of course, some of this from his actual clinical experience, his former education, and of course, many thousands of numbers of individuals, we were able to extrapolate a lot of this, what you now see within the DNA report.
I think I heard you on another podcast and you were talking about the fact that there were interviews with patients that was then cross-referenced with their genetics.
You'd have to remind me of exactly what that podcast was, but we certainly would have had a lot of endpoints within any given patient that we consulted with as it pertains to them having gone through genomics. It wouldn't be exclusively genetics. It would be all types of functional genomic endpoints and laboratory studies and their full clinical medical histories that would have been taken in combination. Absolutely.
Okay. I think maybe it was Chris Kresser. Have you been on his podcast?
No, I haven't yet, actually.
No. Okay. It wasn't Chris Kresser. I can't remember whose it was then.
No worries.
I'll have to look it up. So can you explain for people who may order their own reports what the letters mean for each gene? So for example, I show a list of relevant genes under the hormone section, and here's an example, CYP17A1, and then after that there's an AA, and then there's another one, SRD5A2, and after that there's a CG, and then after another one there's a CC, and after another one a CT, and another one there's a 2.
It's an alphabetical soup. So that's going back to biology 101, grade 11, so 11th grade for most of us. But in essence, yes. I mean, and actually, let's start by take this angle. Most people that are concerned and or interested in this world of genomics, they'll often come across the term SNP first, or single nucleotide polymorphism. We all have them. They're not the more revered mutations. We've all started to come to learn to understand and appreciate this. They're variations on what is not also a theme, but a given natural occurrence, and that is a variation of a particular gene or your SNP, single nucleotide polymorphism variation. So how your particular gene expresses itself, given some genes are nonsense or non-code, and then others are actually making proteins and hormones and doing other things for us. So these important genes that we care to learn about and what they do have different variations. Some are more common to the population. Some are considered, and for the vernacular of this podcast, we'll use preferred variant or poor, not so preferred variant, depending on the context. So when you're thinking or seeing an AA variant given a particular gene, or an AG or a GG variant, these variations may be, given that particular gene and what it does, optimal, suboptimal, average, poor. So it's kind of like getting, in some ways, a report card. But I should say that there is no perfect combination. No one has the best genes. They're simply, what variants do you have, and how, by knowing what those variants are, can you get through this game of life? I mean, genes are the cards that mom and dad have dealt you, I like to say, and how you play them in this game of life is really what matters. So understanding what those cards are is akin to understanding what variations or the numbers or letters that add up as they pertain in some of these instances to your SNPs. So in the DA company, we go further than just looking at SNPs and the conglomerate of variations of those SNPs. We look at pathways, and inclusive within those pathways, often we're looking at copy number variations. So to your point, question around numbers, these are like instruction manuals. We'll talk about this a little bit later on as it pertains to detoxification. In one example, the glutathionization pathway. So how our bodies manufacture, use glutathione in the detox process. You're either getting a whole manual of instruction on how to do that from mom and one from dad. You should have two. Unfortunately, in some cases, we end up with one, or in many instances, null. This is a 0 copy number variation or null variant. And in the case of inserts and deletions, whole lines of code. So maybe not the entire instruction manual missing, but sentences within paragraphs that are just not there. Or in some cases, double sentences. So 2 sentences being redundant of the same thing. These are known as indels, or inserts and deletions. So we're looking at SNPs with the AA, AG, GG variation. Mm-hmm. Which one do you have? We're looking at inserts and deletions, and we're looking at copy number variations. Putting them all together, you can never take one gene out of context. I like to always add that at the end. You have to consider numerous genes, many cases dozens of genes together before drawing even the remotest of conclusions.
Interesting. So when I look at this gene and the letters after it, I don't know what the default preferred variant is for CYP17A1. I have AA, but I don't really know if AA is good or bad.
Well, it's good, let me tell you. But again, that's taking one gene out of context and looking at it on its own. So it depends on what we're trying to accomplish in that instance. And so when we get to hormones, and we certainly will, we'll cover that. That really When we're talking about the hormone pathway, most folks don't understand, or they don't necessarily have yet come to understand, at least, that whether you're male or female, that's decided by the XX or XY chromosomes, that we all produce hormones with the exact same cascade. So look forward to talking about that. And the gene you described is really more specific to how fast you might actually produce estrogen from progesterone. I mean, we'll get into it, and it's a really interesting pathway.
I didn't want to get to the details of that. It was more about understanding that as I look at the report and I see those letters, there's nothing to tell me right off the bat whether what I have is the preferred or not preferred variant. Correct?
That's because you got to take them all together. You really have to look at this as a big book on you. This is your instruction manual, and there's no such thing as good, bad. Really, we look at individual genes and instances where we reflect back to or refer back to the literature. We look at these genes as, optimal variants or suboptimal variants given population dynamics. But it's very interesting. So, in some instances, having what might be considered the perfect gene, two of them might actually not only cancel each other out, but maybe actually a suboptimal combination. So you got to take them all in context and all of them together, and where you live and your ethnicity and how your environment, all these things.
One other question related to that. So that means I have 2 copies of that gene, correct?
That would be correct. Yeah.
Okay.
0 on the CNVs. So when there's CNVs, and in this instance, we're looking at copy number variations or CNVs specific to glutathione and glucuronidization. So those are the specific ones we'll be focusing on today anyway. So the pathways that are responsible for both detoxification and hormones. Okay.
So let's start with the detox pathways. How do they relate to gut health, and what does my DNA report say about mine?
Well, let's just look.
So and let's say what page we're looking at too, of the PDF file that you can find on the show notes page.
So this is when we put all these together and we look at one full and complete list, it's many pages long. And that's okay, but we're going to take a minute just to get down to the very bottom of this. And just to summarize as we do this, again, our focus being how do you intracellularly produce, one of the major focuses anyways, glutathione. Glutathionization is one of the most important antioxidants, if not in some groups believe the most important. Remember, I was telling you at the top off camera, by the way, or off mic, that we don't actually list a specific detoxification sub-report. So what we're going to do is we're going to find detoxification on page 10 of your hormonal report, since we're going to come back to this momentarily here. So what we're looking at in this instance is, as I mentioned, glutathionization, GSTT1, or glutathionized theta. Mm-hmm. So I think I'd love to start before I get into the depth of your particular findings and you would probably agree with me that elimination of toxins, the liver-gut axis, the microbiome interaction, the barrier function, all these play a role. And of course, the gut plays a vital role in eliminating toxins and waste products. And efficient detoxification ensures, of course, that harmful substances are promptly removed from the system, safeguarding gut lining integrity. GST plays a huge role there. When it comes to the liver gut axis, that's the primary detoxification organ. It's functioning very closely linked, of course, to gut health. Bile produced by the liver being one example, aids in digestion and carries waste products and toxins for elimination through the gut. And this is also very much involved in microbiome interaction. So it can very much influence detoxification. And conversely, if you're not able to rid yourself of toxins and metabolites, this influences the composition and function of the gut microbiome. So you exude this is good news when we see the number 2 here next to yours, GSTT1. Oh, I shouldn't forget I mentioned barrier, right? So efficient detoxification eliminates the interaction or inflammation between the barrier and how maintaining that gut barrier, essentially preventing, maybe get into this leaky gut and even leakage, therefore, of toxins into the system and substrates into the bloodstream. So GSTT1, you're supposed to have a copy from mom, copy from dad. You got 2. So you're lucky. This is excellent. This is associated, as our report says here, with an increased enzyme function and clearance of substrates. So that's good. We're also looking at how many GSTM1 or mu1 copies you have. Now, this is the master gene, the GSTT1. Let's call the GSTM1 a very close but important second. You're supposed to also have a copy from mom and dad. You also have two, which is amazing. And therefore clearance and processing of xenobiotics and pharmaceuticals and the reactive oxygen species, you're doing very well on that level. So in fact, you are gene blessed, I guess we could even call it, as it relates to glutathionization. GSTP1 is a good example of some variation in a SNP, or the single nucleotide polymorphism that sits on this gene, RS6095. This is where things may get backed up slightly with you. G variations in individuals we know relate to the ultimate clearance of some things like Tylenol. So that might get a little bit held up. Certain aspects of environmental xenobiotics, those that impact us as it pertains to hormone mimickers and so forth. So this gene, it's a member, obviously, of the glutathione S-transferase gene family, but looking at this as a single phase 2 detoxification SNP, you, in summary, are a little more susceptible to certain things, certain health concerns that are associated with toxins, chemicals, and certain heavy metal exposure. And mentioned gut permeability. Well, there's no direct evidence linking GSTP1 to gut hyperpermeability. We know that oxidative stress is known to influence the integrity of the gut barrier, obviously. And so it's very likely that GSTP1, through that role in mitigating oxidative stress, might very much influence gut permeability. Superoxide dismutase is very important, as we know, as it relates to manganese-driven enzyme and gene. Again, here we're looking at a SNP, and yours being a CT variation. There's this association of a 30 to 40% reduction of superoxide dismutase. So when we're seeing the essentially reduced clearance through the GSTP1 and superoxide dismutase, there's that increased risk of reactive oxygen species accumulating. So you're going to, as you probably already very much are, going to be interested in managing antioxidants. One of my favorites, by the way, as it relates to this, are the tocotrienols. I've done a lot of deep dive into, and in particular, and we can come back to this, but when I look at somebody's report, forgive me, Lindsay, I've seen your whole report. So it's hard for me to hold back when I see
don't hold back.
So there's some instances where, okay, like in this case, we're talking about gut health. Obviously, we just mentioned the linkage to liver and that interconnectivity, but because I know about an aspect of your cardiovascular health, and as you've already allowed me to be fully transparent and revealing of all your results here, this is called the 9p21 gene. And we look at 3 different SNP variants of that gene, and anywhere there's a G, it's considered an elevated risk. And what we're talking about with this gene is the potential of inflammation to the endothelial lining. And as we've known for a long time, and I promise as a very quick digression, I'll come back to gut health real quick. But the recommendation in this case to suggest even something like tocotrienols is manyfold. But this endothelial lining inflammation predisposition that you have, to me, signals appropriate consideration for tocotrienols. So not just because SOD, you've got the CT and GSTP1, you've got also the hybrid AG variant, which tocotrienols do a great job of eliminating or sweeping up the mess, but they do a great job of, and this is the work, by the way, of Dr. Chandan Sen out of Ohio State University. And when projects get funded $25 million year over year by the NIH, there's something there anyway. So really great work done there where they looked at post-MI, post-stroke revascularization and recovery, white matter lesion reversal. So pretty amazing stuff from this. And I've been to Malaysia, by the way, and I'm not speaking on behalf of the tocotrienols that might come out of Africa or Indonesia. I can't because I've never been there, but I hear very terrible things about deforestation. Anyways, tocotrienols from Malaysian, the sustainable palm oil might be the indication here for you because of the 9p21 variation and the predisposition to your endothelial lining, and also how it might actually do a great job managing, I would say, the very slight Achilles heel within your own detox pathways. And by the way, amazing at the research shows anyways, at reversal of NAFLD. So non-alcoholic fatty liver disease with tocotrienols. So a lot of little nuggets there to take.
Yeah, let me interrupt you for a second because sure. I actually had Dr. Barry Tan who discovered a source of annatto tocotrienols, and And we talked all about that. And I have subsequently suggested that for a lot of my clients. And I think I have my parents on them and my fiance on them. And
well, we're on the same page then. And he has an incredible product. And what he talks about, the natto derivative is perfectly good. It doesn't have to be the Malaysian sustainable palm oil, but the tocotrienols themselves are some incredible antioxidants. So it sounds like we both agree.
Yeah. And just so people understand what we're talking about, this is a form of vitamin E.
Yep. Correct. Thank you. And then GPX, glutathione peroxidase.
Page 12 now.
Thank you. Of that report, right? So you're going to scroll down until you hit the hormone report, and then it's page 12 of the hormone report where we see GPX. And your variation here, or variant, is a CC. So first of all, this gene provides instructions for making the glutathione peroxidase enzyme, so which that plays a very crucial role in protecting the body as well from oxidative stress. You're doing well here. You're winning, but it takes basically hydrogen peroxide and other harmful peroxides in the body, turns them into the very benign and neutral water molecule. And then here's where I just took a quick peek as I scrolled down to the end of page 12 and reminded myself of this 9p21 and the fact that you've got this between 4 and 6G association. And again, this is the endothelial lining. So this is all relevant within the context of hormones. But really, we stop the detox conglomerate when we go through the GSTT1, GSTM1, doing amazing there with both copies from both parents, GSTP1 and SOD2. That's where we want to tweak things a little bit for you, right? Manage your clearance from phase 2 into just get this, sweat it out, pee it out, poop it out, get it out, right? And so, if I'm talking to a client that has this combination, I'm often, if they can afford it, obviously that's something that's very important to mention, but I'm often talking about infrared saunas. I think it's amazing. Like your gut is like inverted skin, as you know, better than most. And so getting that skin active and sweating out certain things, especially heavy metals, studies show we might do a better job of it through our sweat pores than we do through our kidney clearance. So that would be the detoxification report in a nutshell.
Great. Hey, this is Lindsay here, just letting you know that if you're tired of dealing with digestive issues like bloating, indigestion, soft stool, diarrhea, constipation, reflux, IBS, IBD, or the numerous health conditions that come about when your gut is off, like brain fog, weight gain, UTIs, fatigue, mental health issues, or complex conditions like fibromyalgia and ME/CFS, that's my specialty. With my 3 or 5 session gut health coaching packages, we'll discuss different stool and functional medicine tests to find out the root cause of your symptoms. I'll interpret the results and provide clear explanations, empowering you to make informed choices for your gut and overall health. And together, we'll develop a customized action plan based on your test results so you can find relief and regain your health and vitality. I come from a functional medicine perspective, trying to incorporate the latest peer-reviewed research and educating you on protocols used by functional medicine practitioners, but devoting lots of time and support to my clients the way a doctor simply can't. If you're interested in a 3 or 5 session coaching package, you can sign up for a complimentary 30-minute breakthrough session, or if you can only afford one appointment at a time, you can book an initial 60-minute consultation. Links for those are in the show notes. Now back to the show. Well, let's move on to methylation. So I'm sure many people have heard about MTHFR, but I know there's a lot of confusion about what that means and how important it is, and maybe some exaggeration of its importance, as well as the ignorance about other genes that play into methylation. So let's dig into that.
Sure. I'm going to go back up a bit here to immunity, and I apologize for flipping all over the place here, but it will soon be defined by the page number within the immunity report.
Right. And we should note that the page numbers restart with each report. So the first one was within hormones, and it
was page 10 through 12.
Right. And now we're going to be inside immunity, you said?
Yeah. Because once again, sort of to our conversation at the top, a lot of these genes and genomic pathways, you will see some repetition. So it won't be exclusively in hormone report that you'll see detoxification. It'll be scattered through. It's very relevant to cardiovascular health and disease. It's very relevant to the hormone clearance that we just looked at. And now as we're in this report, you'll see let's just do it within the cardiovascular support. Okay. So rather than scrolling all the way up to immunity, because again, point taken that cardiovascular, immunity, both of these involve methylation. And I like to I like to talk about methylation almost sort of synonymous with inflammation, but not quite. I also like to talk about this and make it without oversimplifying it, because it's quite a delicate biochemical dance. But I look at it like a relay race, where in this race, you've got 5 racers. And the baton, to bring folks back to, again, biology 101 or so, the baton stands for the methyl group, and the methyl group is CH3. And if any of your racers, obviously, in a relay race drop the baton, that's a problem. And it's not a problem very easily solved by just throwing more batons at somebody. You're disqualified if you drop a baton, but it's of no use. And this will show apparent in a second when we just sort of lay 3 or 4 batons on somebody, because more is not always better. So it's a fine dance, this circle. We've all seen these methylation biochemical pathway circles. And the end game here for us is to understand what type of support you might need through the use of very specific types, isomers of B12 and folic acid, as we may support and fuel this particular pathway given the various SNP associations that you might have. So as they pertain to gut health particularly, just maybe we'll underscore that in context of your podcast, cellular health is huge. And our guts turn over, as you well know, and so does your listening audience, at a very rapid pace. The immune function plays a role here. The microbiome that we already alluded to in respect to detoxification. So as it relates to cellular health, just by example, the methylation pathway, optimal methylation, obviously, and availability of B12 and folic acid are imperative, for maintaining the health and repair of the gut lining with that speed of turnover. And obviously for nutrient absorption, macro and micronutrient, and barrier function. When it comes to immune function, methylation plays a very important role in regulating the immune system at large, but also crucial for managing gut health and preventing conditions like IBD, inflammatory bowel disease, and leaky gut. And then the microbiome, go on and on about this. This is a two-way street almost, but B12 status influences the composition of the microbiome. They play a role in producing some of it, but also this significantly impacts overall gut health in this dance with B12. So MTHFR.
We're on page 9, cardiovascular report.
Thank you. So methyl tetrahydrofolate reductase, we're looking at the SNP variant you've got here being a CT. And I don't want to get overly complicated here, but this is the one that people focus on most often, or the single gene that they may have had presented to them and think this is the end all and be all. And it absolutely isn't. I want to remind folks of that analogy. It's a race. It's a circular race around the track, and they're relay racers. This is just one of the racers. It's one of the most important racers for sure. And it's part of the pathway catalyzing specifically conversion of the 5,10-methylethylene tetrahydrofolate to the active folate. So if we just think it's converting into the active folate. So this 5-MTHF is then utilized as a methyl donor, the B12, for the conversion of homocysteine into methionine. So homocysteine into methionine, this is the job that this is doing. In you, it's associated, the CT variant, to a 30 to 35% on average, the research shows, reduction of enzyme activity with the intermediate 5-MTHF production. So we're not just reporting on this saying, oh, there might be a bit of an issue here. I'm going to tell you at the end of this what kinds of B12 and folate is the right ones for you. Because as I was alluding to, just throwing more batons at your racers or between them is not the solution here, with a higher chance of one picking it up. That's called hypermethylating. That can be a problem as well. And a lot of folks, when they came to learn that they might have a CT or a TT, as you do in this case, a CT, just throwing extra folic acid at it may not be not only the right solution, you could also throw the wrong kind of folic acid at some folks. And depending on genes within the methylation pathway that are non-specific to the variations of the MTHFR gene. Okay. So you wouldn't know what kind of folic acid to consume unless, as we're going to do, you went on in this report. So reminding folks, obviously low blood folate is associated with elevated homocysteine levels and increased risk of cardiovascular disease. It's relevant to you because, again, the 9p21 gene and some others, and we'll talk about them, maybe the ApoE factor. And we know all about early pregnancy and normal fetal development, but the gut association, and again, the speed and turnover of the endothelial, the lining is important to manage, right? Folate serves as an ingredient to manage DNA turnover. So you have this association of 30 to 35% of this enzyme activity. And as folate's crucial for synthesis and repair, we know that it's vital in maintaining, obviously, the health of these rapidly dividing cells in the gut lining. So it doesn't stop there. SHMT1. This is basically taking it's a co-conversion of the L-serine and tetrahydrofolate to glycine and the 5-MTHF actual end result. So this is an intermediate. In general, little sort of clinical pearl, the GG genotype that you've got here, when considered, again, in context of the previous one we looked at, the MTHFR is associated with optimal folate metabolism. And this is looking at concomitant disease risks reduction, like, associated with dysfunctional folate metabolism. So many who have a poor variant also have issues with these cellular processes, including these gut cell turnover and repair. But in you, it's associated with optimal bioavailability and efficient homocysteine to methionine conversion. So here's the bottom line for you, and it's not the case with everybody. You're fine with methylfolate. If somebody didn't have this genetic sequence, then they may want to be taking folinic acid, getting right down to the end of the conversion. But you're fine with folate, methylfolate, or 5-MTHF or quadrifolate, any of those that are out there with the MTHF assignment. And then we've got MTR. You're an AA. MTR catalyzes homocysteine to methionine and uses B12 to do it as the methyl donor in this particular reaction. So in you, this is associated with optimal enzyme activity and conversion of homocysteine to methionine. That's the AA assignment. And it turns out because of this, and I'll explain some other variants in a second, that you're fine with methylcobalamin. So the methylated form of B12. If you had any of these other variants down here, we might be wanting to give you adenosylcobalamin. And again, so that we're not hypermethylating you. We saw this in studies actually done on autistic children who found that they had the 5-HMTR. They called it the SNP. Everyone's got that SNP. It's what variation of that SNP do you have? Right. And when they found out they had this poorer, let's call it, variation of this particular SNP, the TT variation, they were giving them in many cases methyl tetrahydrofolate, right? The methylated form. And in about 15 to 20% of them, they were doing worse. And the question was why? And this was one of the answers that Dr. Mohammed was able to answer, because they weren't assigned these other variants that actually helped them to pass that baton in this race and effectively do so in a way that they were able to methylate properly. And then lastly, your MTRR. This reactivates methionine. You have the version AG associated with a slightly reduced enzyme activity, which won't affect its precursor here, the MTR. So, by the way, MTR and MTRR together influence B12 availability, which of course is crucial for DNA synthesis and maintaining the health of the gut lining. But just having this AG here does not all of a sudden screw you up and cause you to require the adenosylcobalamin. So again, we're still giving you that form of methyl B12. And it's important because this can contribute to things like, B12 anemias and other reduction of available. Which I had. Systemically.
Yeah,
did you?
Following SIBO and what turned out to be post-infectious IBS, and for a time positive for pernicious anemia, my, what are they called? The blood doctor's hematologist. Yep. He recommended that I get on methylcobalamin, and I've essentially been on it continuously for the last 10 years.
Awesome. And it would have worked. But guess what? In some other combinations and other folks with the same looking red blood cell count and differentiation, given that, they may not do as well. They may need adenosylcobalamin. So
lucky guess for him.
Right. And then lastly, fucal transferase, FUT2, the AG associated with slightly suboptimal enzyme function and the plasma levels. This encodes for an enzyme, basically, and this is relevant to you, by the way. It found in epithelial tissues in the gastrointestinal mucosa and salivary glands. So this SNP shows a significant association with plasma B12 concentrations. And in your case, as you mentioned, this would be the gene that I would say, besides some of these up here, that because, again, what happens in the gut. So associated with poor enzyme function, plasma B12 levels all G allele carriers, so whether you're AG or GG, are associated with significantly lower plasma B12 levels. So that doesn't surprise me at all when you say that.
And we're on page 11. So those two markers that are in the suboptimal variant of AG basically mean I should probably, it's not unusual that I should have to continue to supplement with B12 in the form of methylcobalamin.
Yeah, and
folate, methylfolate.
Yeah.
Right.
Yeah. And also, by the way, combined with a vegetarian diet, this variant's associated with extremely clinically low, and like vegan, obviously, B12 levels. So really important to get on that.
Yeah, I'm not a vegan.
Right. Intramuscular, in some instances, or sublingual forms of supplementation.
Yeah, I have always taken it sublingually since that time because of the pernicious anemia and the SIBO.
Perfect. Yeah. So look, I mean, by the way, most folks that run this test, the DNA, by the way, we should remind anyone who doesn't know this, and I'm sure most of your listeners would definitely know this. DNA is one and done. You run this test once, your DNA doesn't change. The most incredible thing is that where you can't alter your DNA, you can manage genetic expression. That's obviously epigenetic. And that's what we're talking about through, in this case, a perfect example, methylation. Manage this by quelling the fire. I don't care what you call it, subduing and mitigating inflammation, but you're managing it in a way, your variations of methylation and how you're able to carry the baton in this relay race with the right formats of B12 and folic acid. It really boils down to that for me anyways.
Yeah.
There's other implications here, but that's really what it boils down to for me for gut health.
Right. Okay. So the third area you suggested we focus on is hormone pathways as it relates to gut health. So how are they related, and what does my DNA say about that?
Yeah, so let's just scroll right back down to keep it simple for folks to the hormonal report, because in this case, we actually call it hormone report, which is toward the end, call it hormones, fitness, and body type. And we'll start right at the top, actually. Let's start here because this is that page, and we use these stoplights, or these traffic lights rather, just to give visual description of speed. So what I want to emphasize here is that, again, I alluded to this earlier, but everyone, whether you're an XX or an XY individual born into this world with those chromosomal differences, we all have the same pathway hormonally. It's the speed at which we conduct, or we produce certain hormones that's going to make the difference here. By the way, so again, obviously, this is not going to define whether you're male or female. So within each of those categories, male X, Y, and female XX, you're going to have this, spectrum. There are certain, there's that spectrum of androgenized females through to estrogenized females and those in between. Same with men. There's androgenized guys and estrogenized guys. The team at the DNA company have gotten pretty close now to looking at somebody and phenotypically being able to give a rough estimate and pretty accurately of what their hormones probably exude from a genomics perspective, because there are certain things. For example, we're all wearing our heart on our proverbial sleeve here and showing I'm an estrogenized guy. I'm probably going to have a full head of hair into my late 80s, as my father and grandfather, both grandfathers did. So that's just one phenotype, obviously. The challenge in my instance is retaining muscle mass as one additional phenotype. It's hard for me. I got to work extra hard. And then you'll have the guys in the gym and they take 1 or 2 days out of the week and they do half an hour and they're ripped and they're bald. And guess what? They might have that advantage, but then certain hormones, an androgenized guy is going to maybe predispose them further to prostate cancer or a BPH for that matter. So how this relates to the gut, because that's what we're talking about here, is the speed at which you produce progesterone into testosterone into estrogen. We know too much or excessive estrogen is very pro-inflammatory, particularly in the gut. And then how you take estrogen and the genes that help clear or metabolize estrogen into their end metabolites. So these are known well for their predisposition into estrogen-related cancers, breast, ovarian, and colon. And then step 3, how you detoxify those. And we've been through some of that, but we can reiterate them. So obviously there's the hormonal influence on gut permeability. We're coming to know that. So variants, and we'll come back to CYP 19A1, which is how quickly you take androgens and make estrogen, which affects estrogen synthesis. And that might directly actually influence gut barrier function. There's the stress response. That's not just an executive function thing. That's a hormone thing, integral to the body's stress response, causing us to, depending on our variations in genetics, susceptible to irritable bowel syndrome. Genes like CYP17A1 that you mentioned at the top that starts this whole cascade here, involved in synthesizing stress hormones. That probably plays a role. And there's got motility. Like hormones and neurotransmitters, of course, influence the speed at which our guts move, right? And how the transit time works. Inflammation, particularly sex hormones, implicated with an inflammatory response in the gut. So variants here, you might not be able to see this here, but I'll blow it up. The androgen receptors, the AR gene and the variations there affects androgen receptor function, of course, but influences inflammation and inflammatory pathways in the gut. There's the microbiome composition. There's immune function, nutrient metabolism, and of course, detoxification. All of these things are going to have a major influence on gut health. So your CYP17A1, how you take progesterone in the steroidal sex hormone pathway and produce testosterone. You see this red light? That's you. You're slow. That's actually great. I mean, we call it great because it depends on everything else I see here, but it's great because it's slow or red light, by the way, does not mean somehow you're stopped, or that you're not making enough. It's not a bad thing. It's the speed at which you're taking this. So given that you have a yellow or a green light on the CYP19A1, or in this case, taking testosterone, making estrogen, this would be, your saving grace here if you were green, the speed at which estrogen sort of overspills in the body. But if you were an amber light here or even a green light here on the CYP17A1 is what I'm pointing at, but then you were an amber or a red light on the CYP19A1, that's a different picture, but I'm sort of painting the sort of scenario of one compensating for the other in terms of overspill, in particular as it relates to gut health of estrogen metabolism, right? So your variation, and we can flip down to those variations, but I know what they are, so I'll just refer to them in context of this picture here for you. Your CYP17A1, you are an AA. So this is, again, responsible for biotransformation of pregnenolone and progesterone to testosterone and the cytochrome P450 cascade. So first step in hormone production, critical in determining the degree of all your hormones, the rest of influence your overall health. So you're a slow converter of progesterone to testosterone. The SRD5A2 is your testosterone into the very virulent dihydrotestosterone, or DHT. And the speed at which you do that is average or in the middle in between. Now, one of the things, like we're talking phenotype, might as well bring it up. It's not so relevant to gut health, but I can tell you, compared to your peers, your friends, whoever, that they're complaining. I mentioned the gym. They're complaining at the degree of what it takes them to work out in the gym and have some level of definition or be lean and somewhat muscular. And then other friends are always complaining about cellulite and fat retention, all these different things. Obviously, I know you pay close attention to your diet. I don't know, maybe there was a time that you didn't, but even in those times, so long as you did exercise somewhat, and if we consider this, the androgen receptor gene here and the speed at which you clear testosterone, you don't have to work as hard as the average person to actually retain muscle mass. And you're not going to be one of those that really notices cellulite. It's just the phenotype that you have. I mean, feel free to correct me if I'm wrong, but at least your genes suggest
not wrong.
it. Yeah. So SRD5A2, this is the 5-alpha reductase that converts testosterone into dihydrotestosterone. You are this moderate enzyme activity. And, we call this potential for elevated dihydrotestosterone. It's worthy of mentioning at this point. These are genes, and depending on your environment, your lifestyle, and so many other factors, the only thing that's going to tell you any conclusive evidence of what's happening right moment in time right now are laboratory biomarkers, right? So endpoints, you can test for DHT, right? You can test for these things. Depending on where you are in your life, these are just the signals or the genes that dictate the average amount over your life and where you sit there. But any given time, you can test for all these different things to know where you are. And by the way, in menopause, and I'm sorry to take another tangent, but it's so relevant to so many things, how you come into menopause is entirely predicted by where you started this cascade. If somebody's very quick to make an abundant amount of testosterone, and by the way, guess where all estrogen comes from? testosterone in guys and in females. It comes from testosterone, and it's the CYP19A1 gene that makes it, and at what speed. But if you're green lit here from progesterone into testosterone, and you're green lit from testosterone into estrogen, what do we call that? We call that estrogen dominant, particularly if how you convert into DHT is relatively slow. It's like a cascade or waterfall. Everything's going into estrogen. And then if you have over here your estrogen metabolites, I'm giving a hypothetical situation. This is not you. If you're producing very little, 2-hydroxy, but a ton of 4-hydroxy and 16-hydroxy, well, then we know what the risks are from that in these estrogen scenarios. Now you're estrogen dominant plus estrotoxic. Right. So these are these sort of scenarios. That's not you, thankfully. In again, with you, you have this potential for producing, high amounts of DHT. And I just described some of the various phenotypes. We got to be concerned or thinking about things like PCOS when there's an elevation or retention of DHT. But your CYP19A1 gene is not at all sluggish or too slow. It's right there in the middle, which is exactly what you want. So again, just to remind everyone listening, this catalyzes aromatase, and this is the very rate limiting step in the conversion of androgens into estrogens, both men and women. And of course, you're this moderate expression with enzyme activity with, modestly reduced estrogen and estrogen to androgen ratios. And again, in postmenopausal, here's my prediction for you. Ready? I don't have a crystal ball, but you're going to have quite an easy menopause.
Well, I can tell you the reality is that the hot flashes are insufferable, and I've had to go on hormones.
Oh, you have? Okay. That's interesting. So the hot flashes may be related to some of those other genes as they pertain to the 9p21 and detox, but I would have predicted a relatively easy menopause. So that's
no other symptoms besides the hot flashes.
Okay, good. Well, that's another predictor.
When I have clients dealing with diarrhea or loose stool, I always tell them about tributyrin, which is the best absorbed form of butyrate, which is normally made by bacteria fermenting fiber in your colon. Supplemental tributyrin can help slow your motility down and feed the cells lining your colon, firming up stool and helping create an oxygen-free environment in the colon, which helps the butyrate-producing bacteria to survive and multiply. Those bacteria are often wiped out after taking antibiotics, which is why tributyrin is a great accompaniment and follow-up supplement if you have to take antibiotics. My new supplement, Tributyrin Max, has 750 milligrams of tributyrin, which is the highest dose currently available in a capsule. You can find it at tributrinmax.com. That's TRIBUTYRINMAX.com, and use code INTRO15 for 15% off your first order.
The speed at which you actually go through menopause is another thing. Nothing I can predict through what I'm seeing here, but how quickly, obviously, your estrogen supplies dwindle, controlled by other genes, would be related in this as well. So
before you go off that, I have a question.
Yeah, go ahead.
So is there anything in here that predicts that I'm going to be low on progesterone?
So we don't look at the genes that ultimately cascade down from cholesterol because they're not as important. Obviously, if you're on a statin and certain things suppress cholesterol or some of the other precursory pregnenolone and so forth, then yeah. But what this suggests is the amount of progesterone that is otherwise circulating at any given time is otherwise average to higher than the average individual. So, and that doesn't mean menopause because those are all going to flunk a little bit. But here's really what I want to drive home. Depending on what kinds of hormones people are otherwise supplementing, bioidentical hormone replacement therapy, there are certain qualifications we like to look at. And this is relevant to gut health, very relevant to gut health. If you are estrogen dominant and estrogen toxic, by taking progesterone even on its own, what's it going to do? It's turning into testosterone, into estrogen. It's not exclusive. You are producing more of that stuff. So if I'm looking at you and I'm looking to determine a candidacy, if you will, for bioidentical hormone replacement therapy or even regular HRT, you're a great candidate. Anyone looking at this would say, or any of our team anyways would say, yes, she's actually qualified, with the exception, and it's a mild exception down here. This is what we're going to get into. Step 2 here is looking at the degree of metabolite production. Again, the speed at which you produce these metabolites. In an ideal world, you would have a green light over here. in an ideal world. And what this is a 2-hydroxyestrogen I'm looking at controlled by the CYP1A1 variant. So, and the reason I say that in an ideal world is because being slow on that, the protective 2-hydroxy is to suggest you're a little more at risk, studies show. And then over here, the 4-hydroxy in an ideal world, it's fine that it's this yellow variant that, it would be red. And 16 would also be red. So how we work this through, though, is, and you're very familiar, I'm sure, with the research around indole 3-carbinol or diindolylmethane and some of these cruciferous family of vegetable extracts, that this helps flip the switch on this, helps to slow down the 4-OHE and over to the 2-hydroxy estrogen. So it helps to increase or helps to speed up the metabolism of the estrogen and clear it.
So eat my broccoli?
Eat your broccoli, bowls and bowls of it, right? In some circles, obviously, the gut health circles, depending on your FODMAP assignment or how well you do, and some of the insoluble fiber levels and so forth, and obviously that's a whole different story. But yes, at the very least, take an extract. And I tend to prefer a diindolylmethane over indole 3-carbinol, I think, in these instances anyways. I don't think you can eat yourself to therapeutic range of broccoli, I guess is my point.
I have at various points taken that for various and sundry reasons. So definitely something I could go back on.
Yeah, I think so. I think it's indicated for you if we're talking about stuff. So far, I think there's 2 things that I would really consider in your daily regime, and that would be the tocotrienols and some indole 3-carbinol, or probably even better, some diindolylmethane. And then this step here that we've already somewhat discussed, we have discussed it at length, glutathionization. We haven't talked about the detoxification ramifications of catechol-methyltransferase, which is also involved in executive function, very important in methylation and converting all the neurotransmitters into active metabolites, et cetera. But it's very important here in excreting estrogens. Now, the reason, and I'm just going to highlight this real quick, you're seeing a red light on GSTs. It's a little bit, and our algorithm works in very mysterious ways sometimes. This is one of them. If you GSTP1, which is true, you have the AG variant, it's going to show up automatically, even though you have a great GSTT1, 2 copies, and a great GSTM1, 2 copies. Your SOD, hybrid variant AG, and your GSTP1. So that's why it says considered suboptimal. So the other thing is maybe again, when we're talking gut health, I still think one of the best things to consider for folks is upregulating glutathione. And I think if you do a quick PubMed search, there's like 32 or 4, something like in the realm of low 30 studies have been done on supplemental glutathione. And 30 or more of them have basically resulted in either no effect or very little effect. And I think what the studies show in summary is that, yes, the glutathione that you might consume in glutathione format, whether it's liposomalized or otherwise reduced or S or whatever, is probably entering to the system, but it's not getting into the cell, intracellular, whether it's the cells of your intestine or into your red blood cells, beyond homeostasis. So it's probably doing some antioxidant good outside of that, but it's not getting beyond homeostasis into the cells. So we like to recommend precursors.
Like NAC or glycine.
You got it. NAC, glycine, exactly, alpha lipoic acid, selenium, a little bit of selenium, or 3 Brazil nuts a day, non-irradiated, organic if possible, Brazil nuts. But there's also some interesting ingredients I think out there worthy of further due diligence by anyone listening to this, and that's gamma-glutamylcysteine. So some interesting studies out of Australia taking this gamma-glutamylcysteine seems to actually upregulate glutathione intracellularly beyond homeostasis. So it's like the direct precursor. Anyways, all of that to say, we're huge fans of precursors to glutathione. We don't think glutathione itself is really going to work. It's probably just going to absorb in the stomach and in the gut and not really do.
What about S-acetylglutathione?
Any of those variants, you look at any of those things and it just doesn't survive. It just gets broken down.
Well, it's a lot more expensive, so certainly easier to get the precursors.
And there you go. Exactly. So in sort of generalized summary, like detoxification and gut health and methylation and gut health, I mean, we're talking about elimination of toxins, liver gut axis, microbiome interaction, cellular repair. That's so huge. Immune regulation, all these things factor in. Neurotransmitter synthesis, we didn't get into that, but obviously we look at the whole brain, gut axis, and executive function. Energy, metabolism, and methylation, all that plays a role. And the interaction between detoxification and methylation, obviously toxin elimination, microbiome, I think I mentioned that. Hormone balance, we just finished some of that. Both detoxification and methylation influence hormone metabolism and elimination, which can impact various aspects of gut health as well, including the motility that we very briefly alluded to, and even immune function. So you're getting to see how all of these things, you can't look at any single gene on its own. Mm-hmm. All of them play a significant interaction, and they need to be looked at in context of pathways. And we're very proud of that at the DNA company, not just what we look at and how we report on them, but the science that supports these various pathways and pathway interactions, I guess would be the quick and dirty summary.
Do you have time for one more question?
Love it.
Okay. So this is a little off topic, but one of the reasons I was really excited to have this report done by the DNA company was because in my 23andMe results, when I ran them through Genetic Genie, it indicated that I had ApoE4 and 4, which is the worst genotype for the risk of Alzheimer's. And I recall reading that meant I had something like an 85% risk of having Alzheimer's by age 80, but correct me if I'm wrong. And so I was waiting for independent confirmation of this. And so I was really relieved when you ran this report and I saw that I only have ApoE1, ApoE4, and 1 ApoE3. So can you tell me a bit about this and the degree of difference in risk profiles for a 3-4 versus a 4-4 and what people can do who have the ApoE4 genes and other genes that are relevant to Alzheimer's?
Absolutely. Yeah. So starting at the top with when we're thinking about where we're getting our information from, or that is to say, the results of a genetic report, we have to consider where it's coming from. And ultimately, unfortunately, some of these genetic reporting companies that are involved in looking at a tremendous amount of genes all at once, this is really more of a cost savings initiative, or let's call it a business model. They can't run small runs of gene sequences. And this gets a little bit complicated, but just save it to say they're running tens of thousands, so your entire genome essentially at one time. That's going to lead to a varying degree of inaccurate reporting, and it's quite widely available. The literature boils this down as basically 15 to 20% of false positive on the ApoE4. So either receiving a 4 or a 3-4 or a 4-4, a variation wrong 15, 20% of the time. I probably shouldn't say this, so I'll just use a very famous TV doctor had this done, and we did these genetic tests for that person. Very unique, actually, presentation, but I'm saying this because he reported his variations on the air. So, but I'm just holding back a little on the story. But at the end of the day, same kinds of situation went down as I'm assuming went down with you, is he was falsely reported on. We correctly reported on. Here's why we're able to correctly report on these. And that's because we run very small runs, really small batches of genetics at a time. So the chances of making a mistake is very low. Mm-hmm. When you look at the literature, what you have to understand about these studies, by the way, see, I'm showing you this on page 4 of the cardiovascular report. That's because we don't report ApoE in context of like some kind of dementia report. So we're not making, now we can talk about it in context of cognitive decline and dementia because it's very relevant to that. But we report first and foremost on this cholesterol carrying capability of the apolipoprotein. And that plays a role. But so you look at these populations and you see those that have essentially had diagnoses of Alzheimer's that were extrapolated and then looked at, depending on literature you read, 30 to 40% of those with an ApoE3-4, 30 to 40% of those with Alzheimer's had an assignment of genomic ApoE3-4, and upwards of 70% had ApoE4 variants. But you can't just jump the gun and so quickly reverse engineer that to mean if I have an ApoE3-4, I have 30 to 40% increased chance of getting Alzheimer's. There's so many different factors involved, as we all know, right? Diet, lifestyle, sleep. We can get into so much here. But so there's a definite association. We don't report on this as the Alzheimer's gene. We can talk Alzheimer's, because having your variation here of a 3-4, there's implications of, again, cardiovascular disease, coronary artery disease, ischemic stroke. And we talked about the combination, or no, we haven't talked about the combination, but putting this in combination with the 9p21, it's definitely a highlight risk for me, for you. And it's something that you want to take away from this report outside of gut health and its implications is cardiovascular disease. So this is very much an old story of cholesterol being part of it. Obviously, size, particle size, oxidative cholesterol, how angry it might be and how quickly it might want to deposit within the lumen of the artery lining. But when we combine ApoE as a 3,4 with a 9p21 multiple G, we're much more concerned about the predisposition of inflammation that warrants the cholesterol, of deposition of that cholesterol, right? Does that make sense? So yes, the studies are there. By the way, third ingredient for you, for me, for you anyway, would be a very bioavailable form of curcumin. And there's multiple ones out there. I like the liposomal curcumin in this case. It's all about bioavailability because it doesn't easily, speaking about the gut, doesn't easily get through the gut into the general circulation. So piperine or pepper can help that. But liposomalizing or micellizing is getting it to even smaller, tiny little lipid particle size that can get absorbed easier. So yeah, I'd say with this gene, we like to make these recommendations in combination with other factors considered that curcumin is advisable for you. But that's a long way of saying there's some inaccuracies in certain other companies reporting on this gene. We can't take it out of context and say it's a direct upregulation or assignment to getting Alzheimer's. But at the same time, can you mitigate or do certain things given the rest of the genome pathways that you're expressing risk? And I think, yeah, you think you can. And that's our whole MO is what can we do through diet, lifestyle, and supplementation to tweak or mitigate genetic pathway expression.
Awesome. Well, this was all super interesting, and I love hearing this about my own genes. I wish I could go through the entire report with you, but I will certainly read it more in detail myself. I really appreciate you giving your time to this, and we will include links on how to order your own DNA report from the DNA company in the show notes. I
appreciate you having me on.
Yeah. Well, thank you so much for being here. Any final thoughts?
I just think understanding our genetics and our gene pathways is an incredibly useful starting point to knowing what more we need to focus on. I think a lot of people are confused about if they're biohacking or what might be underlying. We hear this term all the time, underlying cause. So we know obviously genes and environment play a role and how we grew up and all these different things. But I think it's a great starting point for most people. And if you think about it, it's a one and done test, which I also love. So you're spending in, but you never have to do the test again. And it informs on so much more of what you want to put your efforts toward. And I think that's what people are so confused as to where do I start? Well, you know what's a great place to start the journey, start the process of wellness biohacking, understanding potentially what other physicians, clinicians, consultants like yourself you might want to consider talking to help you navigate and wade through. There's so much to know and learn, right? But there's a great starting point. This is your instruction manual. And if you don't know it, you're at a disadvantage. Yeah.
And I think for people in particular who have very complex health problems that are deep, like chronic fatigue or fibromyalgia or some combo of gut issues and mental health issues and something else, that's the kind of situation where I think that something like this would be useful.
Do we have time for just a quick anecdote? Because
sure.
Okay, thank you. So on that note, this is where we see incredible stuff come out of the weeds when it comes to genomics. So in our clinic, and I mentioned this is going back to the top, talking about Dr. Mohammed, I give him such kudos for figuring this out, the light bulb that went off. We have had all these young patients, young female patients at P3 Health coming in, and it's, what you call out for, where you see more of and do well for, you get more patients, right? So we had all these girls come in with chronic fatigue and fibromyalgia and misdiagnosed Lyme, and we did well at diagnosing Lyme, still do, and couldn't figure it out. This was a huge pool. There was like dozens of these girls, and again, they're mid to late 20s, otherwise should be healthy, eating healthy, tried everything. Okay, what did they all have in common genomically? I'll just cut to the chase. They were null variant detoxifiers. They did not have the instruction to properly detoxify. In combination, the two most striking things, there was a third, but it came third, distant third. The second thing, estrogen dominance with estrogen toxicity. So I alluded to that a little bit. Third thing, distant third, methylation, poor methylators, but nonetheless, poor, like terrible detoxification, methyl estrogen dominant, estrogen toxic. This is a story more about what we got them off versus what we gave them. What did we take them off? Birth control pills. They were not, we're just adding fuel to the fire. So they may have had these predispositions, but they were taking birth control pills, hyper-dominant estrogen, not able to clear it because that COMT and GSTs are reliant, that information there genetically to get estrogen out of the body. So just dumping more estrogen like fuel right onto the fire. So yeah, like 9 times out of 10, maybe more, taking them off their birth control pill has solved their chronic fatigue and fibromyalgia.
Wow.
Pretty amazing. Yeah.
Wow. Very interesting. Well, Thank you so much for your time. This is awesome.
Thanks, Lindsay. Appreciate it. Thanks to all you do.
Well, I feel very lucky that I've gotten this personalized interpretation and supplement advice from the leader of the company. But trust that if you do a DNA company report, you will get supplement recommendations in there as well. And I will provide a link in the show notes for where to get a report. And if you use my link, you'll get 10% off. But I'll give it here too. It's thednacompany.com/HDH for High Desert Health, the name of my business. And if you'd like to support the podcast, you can buy supplements at a discount from my Full Script dispensary, order tests at a discount from my Rupa Health Lab store, or use my affiliate links to eVitamins, bulk supplements, or Amazon. If you'd like to connect with me online, you can follow my High Desert Health Facebook page, join my Gut Healing Facebook group, or join my newsletter list at highdeserthealthcoaching.com, as well as follow me on Twitter or X, Instagram, TikTok, and Pinterest. Links for those are in the show notes. Thanks for joining me today, and here's wishing you all the perfect stool.